Hi, today's lesson is 1.3 prime factorization. Our standard is 6th grade number sense B4, and our objective is that you will be able to write a number as a product of prime factors and represent that product using exponents. So let's take a look at it. All right, so for 1.3 prime factorization, here's our vocabulary words. We have factor pairs, prime factorization, and factor tree. So let's go ahead and use, let's say 48 as an example. Using 48, you have what we call multiplicative operations. They include multiplication and division, okay? Now, these are also known as inverse operations. So inverse operations. Think of, in other words, opposites. The opposite of multiplication is going to be division. The opposite of division is going to be multiplication. So they are also inverse operations, but they're also known as multiplicative operations. Okay, that being said, we're going to break 48 up using our factor tree. So using the multiplicative operation of division, we're going to break 48 up into two parts, okay? So we both know, what we do know is that 24 times 2 would equal 48, and this would be called a factor pair. Right now we're going to create a factor tree. 2 is prime, so we circle that. And let's continue to break 24 up using the multiplicative operation of division. So half of 24 is going to be 12. Again, these are factor pairs. 2 times 12 is 24. 24 times 2 is 48. Okay, continue, because 12 is a composite number, it's not a prime. What we want to do is keep breaking it down until we have nothing but prime numbers. Okay, 3 times 4 is 12. 3 is prime, and 2 times 2 is 4, and these are prime. Okay, so now that we have all of our prime numbers here circled using the factor tree and having all our factor pairs here, what we want to do now is break this up into prime factorization. Here's what I mean. So we can say that 48 is going to be equivalent to, counting the 2's. We have 1, 2, 3, 4. So 2 is our base number, 4 is the exponent, times, and then we have 1, 3. And this, my friends, is what we call prime factorization. Okay. All right, so 2 to the 4th power basically means 2 times 2 times 2 times 2, and then of course the last times 3. All right, so these two would be the same, but preferably we want you to write it like this. All right, students, now I know a lot of you guys are familiar with the fact family triangle. A factor tree is similar, but the branches continue to show the additional information about the fact families. For an example, if we have 24, we know that 24 divided by 6 is 4. We know that 24 divided by 4 is 6. At the same time, we know that 6 times 4 equals 24. So in this sense, at each vertice, that is the corners here of the triangle, at each vertice we do have a number. In this sense, this is we call this a fact family tree. Okay, so we're going to do something very similar to the fact family tree. However, what we want to do is use prime factorization with the factor tree. So starting with 24, we know that two factors that make 24 is 6 times 4. But 6 and 4 are both composite numbers, so we need to continue to break that down until we get prime numbers. We know that 2 times 3 equals 6, and 2 times 2 equals 4. 2 is prime, 3 is prime, 2 is prime, and 2 is prime. Okay? Now what we want to do, we can say, so 24 is going to equal, you see, let's count the 2's. 1, 2, 3. There's 3 2's. 2 times 2 times 2, and then that last 3 there is your prime number. So we can say that we have 4 factors. Okay? Okay, let's do another problem. This time we're going to start with 108. So if we were to divide 108 into 2 parts, then 2 times 54 would be 108. If we break down 54 into 2 parts, half of 54 would be 27. Now, if we look at 27, 27 is still a composite number. So we know that 3 times 9 would be 27. 9, we keep breaking that apart until we get primes. And so once we have our primes, 2 is a prime, 2 is a prime, 3 is a prime, 3 is a prime, and 3 is a prime, then we can say that so 108 is going to be equivalent to, let's count the 2's. 1, 2. We have 2 2's. 2 times 2. And count the 3's. 1, 2, 3. We have 3 3's. 1, 2, 3. So notice that we're going to break, using the factor tree, break 108 into primes. And then with all the primes circled, we're going to write them chronologically, however many there is. Okay, so we have 2 2's, we have 3 3's. Okay, so we can say that there is 1, 2, 3, 4, 5 factors. Okay, if there's 2 2's, we can write 2 to the 2nd power times, and here base number is going to be 3, so we count 1, 2, 3 3's. 3 cubed, or 3 to the 3rd power. Okay. All right. So hopefully that makes sense. And we call this prime factorization. Okay. Let's do the same thing to our previous problem. So if we count 2, we have 1, 2, 3 2's. So 2 is our base number, and there's 3 of them. Times, remember we're multiplying because we have products. We have 1, 3. Now you don't necessarily have to put a 1 as an exponent for 3. You could just leave it as is. But if you want, that's okay too. And our prime factorization for 24 is 2 cubed times 3. Okay, so that is the end of the lesson. And ladies and gentlemen, I do appreciate you guys being here and learning more about prime factorization. By now you should be able to find factor pairs of a number. Okay, we just went over that. You should be able to explain the meanings of prime and composite numbers, and also you should be able to create a factor tree to find the prime factors of a number. And lastly, you should be able to write the prime factorization of a number. Okay, you have a good day.